Hello everyone, welcome to Cloud Pedagogy. In the last session, we have covered few of the VPC components. In today's session, we will learn about Amazon VPC routing and security. First, we'll try to understand why we need routing and security, what are basically route tables are, and we will understand the components like what are the custom route tables. Next, we'll see how we can secure your subnets with network ACLs. And finally, we will see how to secure your EC2 instances with security groups. If you are ready, let's go ahead and start it. Let's take a look at our current VPC state. In the last session, we left off with a VPC with an internet gateway attached to it. We also built additional resources to make sure our application was highly available. So now we have subnets, one public, one private in a different AZs for a total of 4 subnets. We also created an EC2 instance hosting our student directory application inside of the public subnet in AZA. But we are missing one large component here. Say we have a user and that user wants to access our student directory application. Eventually, the internet traffic would flow through the internet gateway. But then, where would it go? Just because the traffic entered through the door of the VPC, it doesn't mean it ever made it to the right room. What we need to do is provide a path for the internet traffic to not only enter the door, but also make sure the traffic reaches the right room. Or in other words, enter the internet gateway and find the right subnet. The way that we provide the path is through route tables. So what are basically route tables are? When you create a VPC, AWS creates a route table called the main route table. A route table contains a set of rules called routes that are used to determine where network traffic is directed. Those route tables can be applied on either the subnet level or at the VPC level. When you create a brand new VPC, AWS creates a route table called the main route table and applies it to the entire VPC. AWS assumes that when you create a new VPC with subnets, you want traffic to flow between those subnets. In the last session, when we talked about VPCs being isolated, this is what we meant. The default configuration of the main route table is to allow traffic between all subnets local to the VPC. Here you can see an example of a main route table. There are 2 main parts to this route table. The destination, which is a range of IP addresses when you want your traffic to go. In the example of sending a letter, you need a destination to route the letter to the appropriate place. The same is true for routing traffic. In this case, the destination is the IP range of our VPC network. Next, the target, which is the connection through which to send the traffic. In this case, the traffic is routed through the local VPC network. Next, we have the custom route table. While the main route table controls the routing for your VPC, you may want to be more granular about how you route your traffic for specific subnets. For example, your application may consist of a front-end and a database. You can create separate subnets for these resources and provide different routes for each of them. Remember, we mentioned that subnets can be used to group your resources together based on whether they are publicly or privately accessible. Well, the subnet itself doesn't provide that access. Whether a subnet has access to the public internet or not depends on its associated route table. If a route table from the internet gateway to the subnet exists, it has public access. If the route table doesn't have a route between the subnet and the internet gateway, then it does not have public access. So we call subnets public or private, but it's really the route table that provides that access. So for your subnets, you will create custom route tables. Inside these custom route tables, you will have the default local route inside of it that allows traffic to flow freely within the VPC. But then you will need to create additional routes. So the subnet with the internet facing resources In this case, our EC2 instance with the SDA website on it. It will need a route to the internet gateway. So, this is our final state of the diagram. One VPC, 4 subnets, one public, one private in both availability zones. Our 2 public subnets are associated with a route table that allows traffic flow from the internet gateway. Our private subnets don't have a route table associated to them yet. So they follow the rules of the main route table, which are local traffic only. Now we will see how to secure your subnets with network ACLs. Now we have a complete network that enables internet traffic flow to our public subnet. But how do we know it's secure? Well, at the base level, we know that any new VPC is isolated from internet traffic. So that prevents risk. But when you start allowing internet traffic by opening up routes, you need other options to keep your network secure. In AWS, you have 2 options to secure your VPC resources: Network Access Control List, which are often referred to as network ACLs, and security groups. Since network ACLs are configured by default to allow incoming and outgoing traffic, you don't need to change their initial settings unless you need additional security layers. Let's apply ACL in our SDA. With network ACLs, you can control what kind of traffic is allowed to enter and leave your subnet. So, if I were to draw network ACLs in our diagram, they are placed around each of our subnets by default. The default network ACL allows all traffic in and out of your subnet. Using this default configuration is a good starting place, but if needed, you can change the configuration of your network ACLs to further lock down your subnets. For example, if I only wanted to allow HTTPS traffic into my subnet, I can do that. I can create a rule in my ACL that allows HTTPS traffic from anywhere on port 443 and denies everything else. However, just because I allow inbound HTTPS traffic doesn't mean my job is done. If I don't open up the corresponding outbound port used for the protocol, then that means that traffic is allowed in, but the web server's response will never leave the subnet. This is because network ACLs are considered to be stateless. I need to include both the inbound and the outbound ports used for the protocol. What that means for our HTTPS example is that I need to allow outbound HTTPS traffic from the subnet to the internet by creating an outbound rule. Next, we'll see how you can secure your EC2 instances with our security groups. The next layer of security is for your EC2 instances. Here, you can create a firewall called a security group. The default configuration of a security group blocks all inbound traffic and allow all outbound traffic. You might be wondering, wouldn't this block all EC2 instances from receiving the response of any customer requests? Well, security groups are stateful, meaning they will remember if a connection is originally initiated by the EC2 instance or from the outside and temporarily allow traffic to respond without having to modify the inbound rules. If you want your EC2 instance to accept traffic from the internet, you will need to open up inbound ports. If you have a web server, you may need to accept HTTP and HTTPS requests to allow the type of traffic in through your security group. You can create an inbound rule that will allow port 80, which is HTTP, and port 443, which is HTTPS, as shown here. As we have already learned in a previous session that subnets can be used to segregate traffic between computers in your network. Security groups can be used to do the same thing. A common design pattern is organizing your resources in different groups and creating security groups for each to control network communication between them. In our diagram, if I were to draw security groups, I would draw them around every EC2 instance in the VPC. We simply just have one EC2 instance, so we would need a security group around that instance. I knew you were all catching up on VPC components, and I knew you were learning. In the next session, we'll go through the lab session where we implement all these theoretical knowledge in the AWS console. See you again in my next session. Until then, take care.